In this first module of Chapter 4 on Reproduction, Module 4.1, I will cover reproductive terms, concepts, patterns, and Lexis diagrams. Reproduction can be characterized in two ways, either physiological, in other words, the process that results in offspring, or demographic, which is the per capita rate of offspring production in a given period of time. The terms reproductive rate, renewal rate, recruitment rate, and natality rate all denote the same reproductive concept and are frequently used synonymously. In biology, fecundity and fertility are sometimes used interchangeably with reproductive rate, but we will use the convention from formal demography of defining fecundity as the total number of offspring a female is capable of producing in a specified age interval, and fertility as the total number of offspring a female actually produces in the interval. Patterns of reproduction. One way to classify the reproductive diversity of organisms is by the number of reproductive events in an individual's lifetime. Semmelparis species reproduce once. This pattern is often termed Big Bang reproduction because individuals die after reproduction. Examples of Semmelparis reproduction include Pacific salmon, American eels, octopods, and bamboo. Iteraparis species, on the other hand, breed more than once and thus exhibit age-specific patterns of reproduction. Examples include most vertebrates, mammals, birds, reptiles, amphibians, and fish, but also humans, of course, and most species of insects. The shape of the age schedule of reproduction is generally classified into three groups, including uniform and age-independent or constant level of offspring production with age, asymptotic and increasing reproductive output with age, a pattern that often occurs in plants and ectotherms that increase in size after reproductive maturity, and triangular, an age-dependent reproductive pattern that starts low, increases to a peak, typically in early middle age, and decreases with age. Some basic concepts. A reproductive age schedule is the per capita age-specific fecundity and fertility rates over specified age intervals or over a cohort's lifetime. A gross schedule is one in which mortality is not taken into account, and a net schedule weights reproduction by the proportion or number in the cohort that survive to each age class. Parameters that express various aspects of this heterogeneity include the following. Reproductive interval, which gives the daily frequency of offspring production among individuals. Daily parity, or it could be yearly parity, which denotes the fraction of the cohort that produce specified numbers of offspring at a given age. Cumulative parity, which expresses the fraction of living individuals within a cohort that have had a specified sum total of offspring at a given age. And the concentration of reproduction, which gives the frequency distribution of lifetime reproduction ranked by individual. Offspring produced by females are often produced as clutches, for example in insects, or litters, for example in rodents. This clutch or litter size designate offspring groupings that can be also expressed as an age schedule. Most organisms produce more than one offspring type, of which the most common category is gender or sex, male or female. All of the reproductive relations discussed here pertain to females and are thus maternity functions. Although only limited effort has been directed towards reproductive rates of males, a number of paternity functions can be patterned after these same maternity concepts. Birth intervals and rates. Variation in reproduction among individuals within a cohort can be quantified by comparing birth intervals and birth rates. Birth intervals provide order, that is an age sequence, duration, that is the width of an age class, and timing, that would be period. And birth rates can be expressed as age and or period specific, or as total reproductive rates. Without adjustments for mortality is a gross rate, or with adjustments for mortality would be a net rate. Basic age-specific birth metrics. If all individuals in a cohort are exactly the same age, period effects on birth rates will, at least in theory and with respect to statistical analysis, have the same impact on all individuals. The schematic shown here in this figure illustrates how a number of reproductive metrics are measured and computed. The hypothetical raw data include the number of offspring by age for each individual in the rows, that is individuals A to D, and columns ages 0 to 4. The summary data include total births by individual, exposure time, which refers to the duration of life for an individual, and average births per epoch, which are the births divided by exposure time. So this would be 9 divided by 4 equal 2.3 for individual A. The summary metrics for the total group of individuals are computed from the sums of each of 3 columns, which shows a total of 24 offspring, 12 epochs exposure, that is average lifetime, and thus 7.3 total births. From these sums, averages can be computed, such as the average lifetime births. 24 divided by 4 individuals equals 6 lifetime births per individual. The average lifetime, 12 epochs and 3 individuals equal 4 epochs. And the average reproduction per epoch, that is 7.3 time units, or epochs, divided by 4 individuals equal 1.8. Lexis diagrams. Birth by age and period. The Lexis diagram can be used to illustrate the measurement of 3 different categories of birth rates in humans when both age and period are considered. We have the Lexis square. This is the number of births within a single period for 2 cohorts in the same age class. In the figure, this total equals the number of births from cohort prior to cohort A, which is 25 births, plus the total from cohort A, or 32 births, that occurred in the year 2000, when individuals were between 31 and 32 years old. The total is 57 births. Lexis horizontal parallelogram. This is the number of births through the time that a cohort is a particular age, and that age covers 2 periods. In the figure here, cohort A produced 32 births in 2000 and 19 births in 2001, when individuals in this cohort were between 31 and 32 years. The total is 51 births. Lexis vertical parallelogram. This is the number of births for a cohort during a single period. In the figure for the year 2000, some individuals from cohort A were between 30 and 31 years, and they produced 27 births. And other individuals from cohort A were between 31 and 32 years and produced 32 births. The total is 59 births. This is all for this first module, module 4.1 of chapter 4 on reproduction.